This is another video over optimization, and the problem that we're going to be doing was problem number 4 off of the review sheet from class. And it asked, well, it tells you a poster has top and bottom margins of 6 centimeters and side margins of 4 centimeters. The design on the poster has a fixed area of 384 centimeters squared. So what dimensions of the poster will give you the smallest area of the poster. So we need to set everything up as far as what we know. Here's our poster. We have a top margin and a bottom margin of 6 centimeters, and we have side margins of 4 centimeters, and of course this isn't to scale, just thought I'd throw that in there. And the design on our poster, the design area, yay, is 384 centimeters squared. Okay, so here's what we know. Our area of the design is going to be equal to our X minus 8, because we just add those two sides together, and that is going to be multiplied by our Y minus 12, because our two margins for the top and the bottom were both 6, and 6 plus 6 is 12. And so that means that the area of the poster is just, XY. Okay, so we got our area for our design, and we're trying to get down to the area of the poster. So let's solve for one of the variables in the area of the design so that we can plug that into the area for the poster. So we will get the area of our design was 384. That was equal to X minus 8 times Y minus 12. And do 384, divide both sides by X minus 8, and the X minus 8 will cancel that one out, and we're left with Y minus 12. So then 384 divided by X minus 8 plus 12, because we're adding 12 to both sides, is equal to our Y. So now just substitute that into our equation up here for the area of the poster. And we have our area of the poster is equal to X times 384 over X minus 8 plus 12. So now we will need to take the derivative of the area for our poster. So this was our equation, and as you can tell we have X times something else. So we're going to be using the product rule. And the something else, our second part, actually has a fraction in it, so we're also going to have to use the quotient rule when we go to take the derivative for our product rule. So it's kind of like a derivative inside a derivative, but y'all should be comfortable with that by now. So we have our poster area prime being equal to the first times the derivative of the second. Okay, so the quotient rule says the bottom times the derivative of the top. So that's going to give us x minus 8 times 0, because the derivative of a whole number or a constant is 0. And it's going to be minus the top, which was 384, times the derivative at the bottom. And so, like I said, the 8 is going to go to 0 because it's a constant, but the derivative of x is going to give us 1, and that is going to be over the bottom squared. So we have x minus 8 squared, plus we're going to have the derivative of 12, which is a whole number, so that's just going to be 0. And then that is going to be our first part of the product rule, which says that we take the first times the derivative of the second plus the derivative of the first, which is just 1, times the second, which was 384. Sorry, I ran out of room. Over x minus 8 plus 12. So whenever we clean that up a little bit, we're going to have x times 0 minus 384 over x minus 8 squared plus 384 over x minus 8 plus 12. So now we can multiply through. So our x right here is just going to be multiplied times that. So we're going to have negative 384x over x minus 8 squared plus 384 over x minus 8 plus 12. So this should be the derivative of the area of our poster. So you can see here we have a fraction and a fraction, and the denominators are not the same. So in order to add those, we need to get a common denominator. So to do that, we can see the x minus 8 squared of our first fraction would be a good place to try to get the other one too. So to do that, we would take our second, which is 384 over x minus 8, and we multiply the top and bottom by x minus 8, and just multiply straight across. So that will give us negative 384x over x minus 8 squared plus 384x minus 8 times 384 is going to give us 3072. And that is going to be over x minus 8 squared. And since those denominators are the same, you can add those two together by basically just extending the line out. And we just move that over to make it easier to see. And we still have our plus 12 out here. So we can clean that up even more because we have a negative 384x and positive 384x, so those are going to cancel. So that would just leave us with negative 3072 over x minus 8 squared plus 12. So here we have the area of our poster is the derivative of the area of our poster is equal to negative 3072 over x minus 8 squared plus 12. Okay, so it told us to find the smallest area, which would be a minimum. So to do that, we just set a prime equal to 0, our area prime equal to 0. Subtract 12 from both sides. And you will multiply both sides by the x minus 8 squared. So that side will cancel. So we have negative 12 x minus 8 squared is equal to negative 3072. Then divide both sides by negative 12. And that will give us x minus 8 squared is equal to, we have a negative and a negative, so we're going to have a positive. And that 3072 divided by 12 is going to give us 256. So then take the square root of both sides to get rid of the x minus 8 squared. So when we take the square root, we're going to have x minus 8 is equal to the square root of 256, and that is equal to 16. So now add 8 to both sides to get x by itself. So x is going to be equal to 24. And as you notice, x minus 24, the 24 is positive, and so that tells us that we have a minimum. Okay, so we found x to be equal to 24, and if you remember way back from the beginning, if you don't, you can go back and look, but we found that y was equal to 384 over x minus 8 plus 12. So if we substitute in 24 for our x, we get that y is equal to 384 over 24 minus 8 plus 12, and that is going to be equal to 384 over 16 plus 12, and 16 will go into 84, or 384 24 times. That's plus 12 still. So we have our y being equal to 36. Okay, so we found dimensions for our x and for our y. So, if we want to double check and make sure, we had the area of our design. Oops. Was equal to x minus 8 times y minus 12, and we said that we found x was 24 and y was equal to 36. So just plug in those values. Area of the design is equal to 24 minus 8 times y minus 12, and our y is 36. So that would give us area of our design being equal to 16 times 24, and whenever you multiply those together you get 384, and we were given that the area of our design was a fixed 384 centimeters squared, and the values that we found were in units of centimeters. Should have carried that out, but so anyway, that checks out. And so the dimensions of our poster that will give us the smallest area is a 24 by 36 centimeter poster for the dimensions.